The topic we are going to discuss is NFA to DFA conversion. The given regular expression ARB raised to the power star ABB. First, we have to draw NFA transition diagram. The given diagram 0 initial state, 10 finals. From state 0, an epsilon transition leads to state 1. At state 1, there are 2 epsilon transition. One goes to state 2, where 2 to 3 A is accepted, and one goes to state 4, where 4 to 5 B is accepted. From state 3 and 5, an epsilon transition leads to state 6. This part is A or B, that is A union B. Then 6 reach to 7 through epsilon. From 6, we reach back to 1, and from 0, we can reach to state 7. These two together implement the ARB raised to the power star part. Then we concatenate with the ABB. From state 7 to 8 through A, from 8 to 9 through B, from 9 to 10 through B. There is a concatenation ABB. Here 10 leads to accepting state. Now we are going to compute epsilon closure of initial state. Here initial state is 0. That is epsilon closure of 0. The epsilon closure of a state is the set of states that can be reached from that state using only epsilon transition without consuming input symbols. For conversion to DFA, we begin with the epsilon closure of start state of the NFA, which is state 0. From state 0, we can reach state 1 through epsilon. From 1, we can reach state 2 and 4. But since we are computing only epsilon transition, not actual simple transition need, we only consider epsilon transition. From state 0, we can reach state 7. So epsilon closure of 0 going to be 0, 1, 2, 4 and 7. Here you write epsilon closure of 0 equal to 0, 1, 2, 4, 7. This is considered the first DFA state and we name it capital A. Now we start building the DFA using subset construction. Each DFA state represents a set of NFA states. We begin with the state capital A, that is 0, 1, 2, 4, 7. For each input symbol A and B, we compute DFA transition of capital A, input symbol A equal to epsilon closure of move open bracket A, A, close bracket. Here all the NFA states reachable from capital A on small a. Then we apply epsilon closure to the result to find the new DFA state. From state capital A, we have set of numbers 0, 1, 2, 4, 7. 2 and 7 leads to 3, 8. Remainings are epsilon transitions. Look at the transition diagram. 2 seeing a symbol A reach to 3. 7 looking a symbol A reach to 8. Here you write move capital A, input symbol A is 3, 8. That is epsilon closure of 3, 8. Now we compute epsilon closure of 3, 8. Look at the transition diagram. From state 3 we can reach 6 and 7. Here you write 3, 6, 7. From 6 we reach back to 1. 1 reach to 2 and 4. Write 1, 2, 4. From 8 we can reach nothing directly, but 8 leads to 9 on B. So we ignore it here, but we have to include 8. Here you write 8. So epsilon closure of 3, 8 going to be 3, 6, 7, 1, 2, 4, 8. This is named DFA state capital B. Next, apply the input B. DFA transition of capital A, small b equal to epsilon closure of move A, B. Move A, B. From state A, we have a number 0, 1, 2, 4, 7. The given number state 4, B leads to 5. Look at the transition diagram. From state 4, looking a symbol B, reach to 5. Remaining states, there is an epsilon transition. Here you write 5. So epsilon closure of move A, B. Here A, B is going to be 5. Then we have to find epsilon closure of 5. Look at the transition diagram. From state 5 reach to 6, 7. Right? 5, 6, 7. From 6 we reach back to 1, 1 reach to 2 and 4, right? 1, 2, 4. So epsilon closure of 5, 5, 6, 7, 1, 2, 4. Then rewritten as 1, 2, 4, 5, 6, 7. This is named DFA state C. We now repeat this process for newly found DFA states B and C. From DFA state capital B 3, 6, 7, 1, 2, 4, 8. On input A, the given number 2 seeing a symbol A reach to 3. Here you write 3. 7 seeing a symbol A reach to 8. Here you write 8. Move B comma A is going to be 3 comma 8. So epsilon closure of 3 comma 8. We already found 3 comma 8 is going to be 3, 6, 7, 1, 2, 4, 8. This is B itself. DFA transition of B comma small b equal to epsilon closure of move B comma small b from state B 3, 6, 7, 1, 2, 4, 8. From state 4 and 8, B leads to 5 comma 9. See the transition diagram. 4 B leads to 5, 8 B leads to 9. Write 5 comma 9. Now compute epsilon closure of 5 comma 9. From state 5 through epsilon, we can reach 6, 7. Here you write 5, 6, 7. Then from state 6, we reach back to 1, 2, 4. Here you write 1, 2, 4. 9 from state, there is no epsilon transition, but we have to include it. Write 9. Then finally you will get 5, 6, 7, 1, 2, 4, 9. Here we got new set of numbers. Then rewritten as 1, 2, 4, 5, 6, 7, 9, named DFA state capital D. From state C, we have a different set of numbers 1, 2, 4, 5, 6, 7 and apply the input A and B. DFA transition of C, comma A equal to epsilon closure of move C, comma A. The given set 1, 2, 4, 5, 6, 7, 2 and 7 leads to 3, comma 8. Look at the transition diagram. 2 on seeing a symbol A reach to 3. 7 on seeing a symbol A reach to 8. Then move C comma A going to be 3 comma 8. After that compute epsilon closure of 3 comma 8. We already found epsilon closure of 3 comma 8 going to be 1, 2, 3, 4, 6, 7, 8. We named it capital B. So this is B itself. Next DFA transition of C comma B epsilon closure of move C comma B. From state C, 1, 2, 4, 5, 6, 7, 4B leads to 5. The given transition diagram, 4 seeing a symbol B reach to 5. Here you write 5. Then compute epsilon closure of 5. What is epsilon closure of 5? We already computed epsilon closure of 5 going to be 1, 2, 4, 5, 6, 7. It considered as capital C. So the given set is C itself. Now we compute a transition from state D 1, 2, 4, 5, 6, 7, 9. Apply the input A and B. DFA transition of D comma A epsilon closure move D comma A. From state capital D, we have 1, 2, 4, 5, 6, 7, 9. The given number 2 and 7 leads to 3 comma 8. See the transition diagram. 2 A leads to 3. 7 A leads to 8. Write move D comma A going to be 3 comma 8. Then compute epsilon closure of 3 comma 8. So we found 3 comma 8 already. 3, 6, 7, 1, 2, 4, 8 is going to be capital B. Here you write. So this is B itself. Next, one more input B, DFA transition of D comma B equal to epsilon closure of move D comma B. From D, the given set 4 and 9 leads to 5, 10. The given transition diagram 4 B leads to 5, 9 through B 10. Then write move D comma B going to be 5 comma 10. Then we have to compute epsilon closure of 5 comma 10. From 5 through epsilon, we reach 6, 7. Write 5, 6, 7. From state 6, we reach back to 1, 2, 4. Write 1, 2, 4. 10, there is no transition, but we have to include it. Finally, you get 5, 6, 7, 1, 2, 4, 10. So the given numbers are, there is no repetition. Then named DFA state capital E. Now we repeat this process for the newly found DFA state capital E. Apply input A and B. DFA transition of capital E comma A equal to epsilon closure of move E comma A. The given set 2 and 7 on input A leads to 3 comma 8. 2 A leads to 3, 7 A leads to 8. Here you write move E comma A is 3 comma 8. Now we have to compute epsilon closure of 3 comma 8. What is 3 comma 8? So we have a answer epsilon closure of 3 comma 8 going to be capital B. So here you mention capital B. Next DFA transition of E comma B epsilon closure move E comma B from state capital E containing the numbers 5, 6, 7, 1, 2, 4, 10. 4 on input B leads to 5. In this diagram 4B leads to 5. So move E comma B is 5. Now find epsilon closure of 5. We already found epsilon closure of 5 going to be 1, 2, 4, 5, 6, 7 named as capital C. So this is C itself. Now we cannot repeat this process because there is no newly found DFA states. Now make a transition table and a transition diagram. In the transition table, Q is a set of states. We have two inputs A, B. The DFA has 5 states. A starting state, intermediate states are B, C, then D and E. State A, on seeing a input symbol A, B, it reaches to B and C. Here you write B, C. State B, looking at input symbol A, B, reach to B, D. Right, B, D. State C, seeing input symbol A, B, reach to B, C. Right, B, C. From state D, on input symbol A, B, reach to B, E. Here you write B, E. From state E, seeing input symbol A, B, reach to B, C. Write B, C. The given transition table, A is our starting state, E is our final state because it accepting states since it includes NFA state 10. Now draw the transition diagram. The given transition diagram, A is our starting state, E is our final state. State A on input A reach to B. State A seeing a symbol A reach to B. State A seeing a symbol B reach to C. State A on input B reach to C. B on input A B. B on input A B. B on input B D. B on input B D. C on input A B. C on input A B. C on input B C. C on input B C. D on A reach to B. D on A reach to B. D on B reach to E. D on B reach to E. E on input A reach to B. E on input A reach to B. E on input B reach to C. Now we are going to reduce the deterministic finite automata. The given transition table, A is our starting state, E is our final state. The non-final states are A, B, C, D. Final state E. From state A on input A, B, we have a transition B, C. C on input A, B, we have a transition B, C. Now non-final states are A, B, C, D. Final state E. In the non-final state A and C, there is a transition BC, BC. Now we are going to merge these two lines. You will get reduced DFA. So final state is E, non-final state A, B, C, D. The given non-final state, state A and C, on seeing input symbol A, B, it reaches to BC, BC. So we are going to merge these two states, A, C, remaining B, D. Now we will get A, B, D, E. Instead of C, we will substitute capital A. Then remaining states are B, D, E. Finally, you will get A, B, D, E. So the reduced DFA is State A on seeing a symbol A reach to capital B, write B. State A seeing a symbol B reach to C. But instead of C, we will substitute capital A because we already merged AC. Write capital A. Next, B on AB, BD. Here you write BD. Next C, we remove this line. Then D on input AB, BE. D on input AB, BE. From state E on input AB, reach to BC. BC. Instead of C, we will write capital A. I hope you all understood the NFA to DFA conversion. If you have any doubts, feel free to ask in the comment section. Thank you.